Hey, this is Mr. Aiden. Welcome back, Pre-Calculus Honors. We are in Chapter 6, which is additional topics in trigonometry, and we're going to start off with Section 6.1, which is the law of sines. And so the law of sines, make sure your calculator is in degree mode. If your calculator is in radians, it's going to mess you up big time. So make sure you're in degrees. And the law of sines deals with every type of triangle possible. And you can see, to find this type of triangle, side A divided by sine of angle A, and hopefully you can see angle A and side A are opposite of each other, is equal to B over sine of B equals C over sine of C. And it can be either this proportion or it can be the opposite proportion, and this works for every single triangle. And what else for triangles do we know? Angle A, angle B, and angle C equal 180 degrees. So let's get to some law of sines problems to see if we know what the heck we're doing, and we're going to kind of go through each type of problem. Here we're given two angles and one side. We call this angle, angle, side. And so what I do every single time I do one of these problems, I basically set up my law of sines, and I'm going to plug in what I know. And so you can see side A, I don't know, but sine of A, well, how do I find sine of A? What do I know about these three angles is 29 degrees and 102 degrees plus side A equals 180 degrees. So I can take 180, subtract by 29, subtract by 102, and I get 49 degrees. So I know that this is sine of 49 degrees. Side B, you can see, is 28 feet, so we're going to put 28 feet. The angle B is opposite of that. That's sine of 29 degrees. And side C we don't know, but sine of C is 102 degrees. So how am I going to do this? I can do cross multiplying. I can do proportions. So I'm going to take 28 sine of 49, and I'm going to divide by sine of 29, and I end up getting 43.59. And so I'm going to just call that A, 43.59 feet. Okay. To find C, again, I'm going to do a little bit of cross multiplying. I'm going to do 28 times sine of 102, divide by sine of 29 degrees, and I end up getting 56.49 feet. And you can see we kind of rounded to two decimal places. That's okay. So again, you're just doing cross multiplying, and you end up getting your law of sines to find your remaining angles and sides. Okay, so that is when we have angle, angle, side. What if we have angle, side, angle? Again, I have side A right here, divided by sine of A, sine of 43 degrees, equals B, I don't know what B is, over sine of, what is this angle right here for B, is going to be 98 degrees. Okay, 98 degrees. Side C is 22 feet. Okay, they gave me that right there. Angle C, how do I find angle C? Well, what do I know about all my angles? They're going to add up to 180 degrees. So I'm going to do 180 degrees minus 43 minus 98, and that gives me 39 degrees. Why? Because all of these angles add up to 180 degrees. Now I can do some cross multiplying to find out my leftover sides. So I'm going to do 22 times sine of 98 divided by sine of 39, and I end up getting side B to be 34.62 feet. And again, I can either do this proportion right here between B and A, or I can go back to C and do 22 sine of 43 divided by sine of 39, and side A ends up being 23.84 feet. Okay, and so make sure your calculator is in degrees, and you can do this proportion, and you can do it any way you want, as long as you do the proportion evenly. Now, if you see side angle, okay, side angle, flip that around, and you can know that you have the possibility of having a single solution, no solution, or two solutions. And so once you see the ASS triangle, you know you have the possibility of having a single solution, no solution, or two solutions. And so I do these always the same exact way when you have this angle side to side. Okay, is I always put, I kind of do this in two different colors, okay, and I'll show you why I'm going to do this in two different colors. So we know side A is 22. I know sine of 42 degrees goes with the A. I know B is 12 over sine of B. And then I have C over sine of C. Okay, so that's locked in stone. That's locked in stone. And so we have the ability to possibly have one triangle, maybe two triangles, maybe no triangles. Okay, now in this case, this is going to be a one triangle case, but I'll show you why this is not a two triangle case. Okay, and so we're going to do our cross multiplying. We're going to do 12 sine of 42 divided by 22. So 12 times sine of 42 divide by 22, and remember that ends up, when I did my cross multiplying, I got 0.365, do that in your calculator, and that equals sine of B. Now remember, how do we find out what that angle B is? How do we figure out what that angle B is? We have to do arc sine, the other side. So we do sine to the negative 1 of 0.365 to equal angle B. So we do arc sine of that answer, and we get 21.4 degrees. 21.4 degrees. So I know angle B is 21.4 degrees. Okay, so I'm going to kind of erase this B right here, and I'm going to put 21.4 degrees. Now, you can see, how do I figure out what angle C is these angles should always add up to 180 degrees. So I'm going to do 180 degrees minus 21.4 minus 42, and I get 116.6 degrees. 116.6 degrees. That works, which means you can see how I'm going to do another cross multiplying here to find out this side C. Okay, and so I'm going to do sine of 116.6 times 12 divided by sine of 21.4, and I get a side C of 29.4 inches. Because that was inches and inches. Okay. Now, anytime you have an angle side to side, you have the ability or the possibility of having either no triangle happen, one triangle happen, or two triangles happen. Now, if you can see, this first angle I found was right here, this 21.4 degrees. Now, if there is two triangles, then it will be this second triangle, it will be the supplementary angle to this first angle you found. So you take 180 degrees minus 21.4 degrees. So I take a 180 minus 21.4, and I get 158.6 degrees. Okay, so the second triangle has the possibility of 158.6 degrees. Okay, now remember, all of your angles should add up to 180 degrees. So let's take a look. We have 180 minus 158.6 minus 42, and guess what? We get negative, which means we can't have this other triangle. These angles add up to more than 180 degrees, which means we are left with only one triangle that we found up here, that one triangle, that single solution case of angle side side. Now let's say we have another angle side side, and we want to figure out what's going on. So let's take a look. So we have side A is 15, angle A is sine of 85 degrees, okay? Side B is 25, sine of angle B, C over sine of C. Now remember, I see angle side side. I know we may have one triangle, we may have two triangles, and you're like, Aiden, I know it's going to be no triangles. I know it'll be no triangles, but guess what? If I give it to you on a test or quiz or something like that, you don't know if there's two triangles. You don't know if there's anything. So I always kind of write down there's the possibility of two triangles. Okay, So now I'm going to do my cross multiplying. So I have 25 times sine of 85 divided by 15, and I get 1.66 is equal to sine of angle B. Now I'm going to do arc sine. Arc sine of 1.66. Now if you remember back to last chapter, that sine can't be greater than 1, can it? Okay, the domain is only going to be up to 1. So if you do arc sine of 1.66 in your calculator, you're going to have it whack out. There's going to be no possibility of an angle, which means if there's no possibility of an angle here, there's no possibility of an angle here. We have no solution here for that ASS case. Okay. Now let's see if we have two solutions. Again, we're going to do the same thing. We have 12 over sine of 20.5 degrees equals 31 over sine of B equals C over sine of C. And I always do, anytime I have an ASS case, I always do two different triangles, okay? Because I have the possibility of two different triangles. Again, I'm going to do my cross multiplying. So 31 times sine of 20.5. I'll do that on my calculator. So I'm sine of 20.5 divided by 12. I end up getting 0.905. That equals sine of B. I can do arc sine of B, arc sine of that answer, and I get 64.8 degrees. So I get 64.8 degrees. Now again, I'm going to find angle C by adding them all up to 180 degrees. So 180 degrees minus 64.8 minus 20.5, and I get 94.7 degrees, which means angle C. I can do my cross multiplying again. 31 times sine of 94.7 divided by sine of 64.8 ends up giving me 34.1 meters. Okay. Now, how do I find out what this possibility would be for this second triangle? Is you're going to do the supplementary side here, the supplementary angle. So 180 degrees minus this angle B, this first angle we found here. So 180 degrees minus 64.8 ends up being 115.2 degrees, which means let's take a look at angle C. These should all add up to 180 degrees. So 180 degrees minus 115.2 minus 20.5. Now, again, if these two angles add up more than 180 degrees, you don't have a second triangle. But in this case, we do. We have 44.3 degrees. Okay, it had the ability of having a second triangle. Okay, and so you can see how this angle C right here, side C, we can find out side C by doing my cross multiplying again. 31 times sine of 44.3 divided by sine of 115.2, and we get 23.9 meters. And we had the ability of having two triangles. We had the ability of having this first triangle right here, and we had the ability of having the second triangle. I hope you can see is that angle A, side A, 12 meters and 12 meters, it's the same. Side B, 31 meters, it's the same. Angle A, 20.5 and 20.5, the same. Do you see how what I had in black here is set in stone? It is set in stone. These are not changing. That's why I put these in black. I put everything else in red because those are changing. You can see in this red right here, we have 64.8 degrees. That was my angle there. And the supplementary angle right there, 115.2 degrees, is what we had right there, which therefore changes this sine C and side C. Okay, and so that is where we have two solution cases. Now we can also find the area of an oblique triangle by using, it's kind of like my 1/2 base times height formula, except for it's 1/2 side B times side C times sine of angle A, or 1/2 of AB sine of C, or 1/2 AC sine of B, and I'll kind of show you how this works out. You can see, hopefully, we have side A, side B, and angle C, which means the area is going to be 1/2 A times B sine of C. So we have 1/2 of A is 90, B is 52, sine what is angle C? 102 degrees. So you have 1/2 of 90 of 52 of sine of 102, and we end up getting an area of 2288.87, and of course it's meters times meters, meters squared right there. Now again, if you don't know, now I know you're thinking back, this would have been helpful in geometry when we had to do this all geometrically. Yeah, there's an algebra way to do it, which is a very, very easy formula. You don't have to do all the geometry that you once did. And so you can see how here for this problem, we have a triangle here. We want to know what's the approximate total distance of the race course. You can see the boat starts at A, it goes to B, then it goes to C, then it goes back to A. Okay, and we know from A to C, we're just going to label some sides here. Okay, so I'm going to label that side A, side B, side C. Actually, I don't want to do that. Since this is angle A, I'm going to call that A. Since this is angle C, I'm going to call that C. Since this is what we call angle B, I'm going to call this B. All right, that's a little bit better, isn't it? Now, what else do I know? If this is 40 degrees, then I know this is 40 degrees. How do I know that's 40 degrees? Is geometrically, those two lines are parallel with each other, and so the interior angles are going to be the same. How do I know what angle B is? Well, I'm going to take 180 degrees, subtract by 40, subtract by 52, and that gives me 88 degrees. Okay, so let's see what we have. Side A. I don't know what side A is, but I know angle A is sine of 52 degrees. Side B I know is 8 over sine of 88 degrees. And side C, I don't know what side C is, but we know sine of 40 degrees. Okay, so I'm going to do a little bit of law of sines here, cross multiplying 8 times sine of 52 divided by sine of 88, and that gives me a side of 6.3. Okay, and of course that's kilometers. We know this is kilometers, which means I'm going to do another cross multiplying, 8 times sine of 40 divided by sine of 88 degrees, and we get 5.1 kilometers. 5.1 kilometers, which means the entire race, the distance of the race was side A, 6.3 plus 8 plus 5.1. That gives me 19.4 total meters, and that is the application of the law of sines. Tons of applications of law of sines. We actually used the law of sines back in 1850 to find the height of Mount Everest, and they were within, I think, 30 feet or something like that of the actual height using the law of sines. Pretty cool. And so that is the law of sines, chapter 6.1. I'll catch you on the flippity flop. See you guys.